Hello and welcome to another Roblox Scripting tutorial. Today we're going to be going over how to use a Bezier curve to create a nice smooth path for a bird, in our case a seagull, to fly along. We'll briefly discuss what a Bezier curve is, and then we'll break down how to script everything to visualize the curve as you can see here, and finally we'll get our seagull to follow the curve, in this case from one end to the other. Without further ado, let's get started. Alright, so I looked everywhere for someone walking through getting an AI bird, an NPC bird, to fly naturally along a curve like what we're going to be setting up today, and I couldn't find anything relevant aside from the Bezier curve stuff out there, so hopefully I'm not alone and this is going to help others out there looking for the same thing. Should note that this is going to be a two-part episode, one covering the Bezier curve and the basic movement of the seagull. Then I'll have a second video later which shows a more advanced version of the seagull movement script, where it pseudo-randomly selects an endpoint or landing point, if you will, generates this Bezier curve we'll be making today, and then flies at the correct speed along the generated curve. So make sure to subscribe, hit the notify bell if you want to get notification when that second part goes live. We can't talk about a Bezier curve without first talking about linear interpolation. Linear interpolation, or Lerp, is how you get an unknown value between two known values. In our case, we need to find where on our curve to spawn a coordinate for our seagull to fly to using a quadratic Bezier curve. So in this example, you can see each of these 9 colored points sits at a 10% mark along each line, which is exactly what we're going to be doing as well. To calculate this, we take the two known points, for example, our start point and our control point, which is this top point here, the X. But instead of just finding the halfway point between those, we need to feed in how far into our curve we are. So we're going to feed in the value that's essentially a percentage, since t is a parameter that ranges from 0 to 1. I'm calling this t based on this formula for the Bezier curve. It's worth noting you don't 100% have to know how this works to accomplish anything using a Bezier curve. If you're following along with me, just know the two functions we're going to be making right now are crucial in getting you the proper results. So let's go ahead and create a new script inside of our server script service. And we won't be following our own advice on script structure from our previous videos just yet, since this script's eventually going to be moving into the seagull. So I'm going to name this script, and I am using a slightly different layout just to give myself a little more screen space here. We're going to go ahead and name this script Bezier Curve. When we put this into the seagull, we'll probably rename it. But for now, what we want to do is we want to start by making a Lerp function. So I'm going to go ahead and come a line down here. I'm going to say function Lerp. Increase the size of this just a little bit. We need 3 parameters here. The t I mentioned a moment ago, so we'll put that in. And the 2 points that make up the start and end of our line, I'll just label these A and B. Now with this function, we're going to be moving forward on our curve, so whatever result we get needs to be added to our first point. So we're going to go ahead and return the result of this following equation here. So we'll start with A, we're going to add, because again we're adding to our starting point, and then inside parentheses we'll subtract our first point from our second point, so B minus A, and that will give us the difference. We do this in parentheses because of course mathematics dictates we do what's in parentheses first, then multiplication or division before addition or subtraction. So finally we're going to go ahead and multiply our result by t, whatever our t value is going to be. And then of course this all gets added to A, and that's it for our Lerp function. Super simple. Now that we have our Lerp function finished, we can move on to the Bezier curve function. I'm going to name this quadBezier, which stands for quadratic Bezier curve. So just to break this down, a linear curve is a quote-unquote curve between 2 points. Given distinct points, we'll say point 0 and point 1. A linear Bezier curve is simply a line between those 2 points and can actually be interpreted as a linear interpolation, or a Lerp. A quadratic Bezier curve is a curve between 3 points, as we saw earlier in this image. Given points 0, 1, and 2, which can be interpreted as the linear interpolation of corresponding points on the linear Bezier curves from point 0 to point 1 and from point 1 to point 2 respectively. That's what we're going for. There's also cubic Bezier curves for 4 points and so on, but quadratic is perfect for our simple needs. we need to feed in 4 arguments into this function. So again, we need our t variable, and then we need our 3 points. We're gonna go ahead and use some parameters here. I'm gonna say p0, p1, and p2. Now, as mentioned, we're essentially just interpolating between 2 lerps. So all we need to do is say lerp1, or we'll do L1 is a lerp. We'll call our lerp function here. We're going to go between 0.0 and 0.1, and of course we need to use t. So we feed in t, and then our a is going to be 0.0, and our b is going to be 0.1. Then our second lerp, L2, is going to be basically just a lerp between, we'll feed our t in there, 0.1 and 0.2. So that gets us our 2 lines, our 2 lerps of our lines. And then we're going to get a result, which we'll call quad, local quad. This is a lerp between our 2 lerps. So we're going to use our lerp function again. We're going to pass in our t as before, and this time we're going to use L1 and L2. And that will actually give us our actual curve. So now from this function, we just want to return that quad value, whatever value we get from that. And that's most of the math down. We can actually now collapse these 2 functions, make some more room for the real work now. To show this curve working, I'm going to be implementing some debug parts that will help visualize what we're doing. Normally, we would just have these transparent and you wouldn't actually see the parts go in. So let's go ahead and start by making 3 points, right? Or 0.0, 0.1, 0.2. We'll do this as parts in the workspace. So I'm going to go ahead and come in here and create a part. I'm actually going to go ahead and make sure that this part is anchored. We're going to go in and set the part size to 1, 1, 1. So it's just a 1 by 1 by 1 square. We're going to go ahead and turn it black just because. I'm also going to go ahead and set this to 0 and 0 on the X and Z axis. So it's basically just right in the center of our world. You can even see I've got my little spawn click there. So let's take our part and rename it to point A. And then I'm going to duplicate it using Control D or Command D. I'm going to duplicate it twice. We'll take the second one and we'll name it point B, and the third one, and we will name this point C. So pretty simple. So point C, we want to just move forward on the Z axis. So let's go to the position here and let's move it, let's say 40. Yeah, 40 should be good. Point B, I'm actually going to use this as my control point, the X as you saw in the previous image. So in this case, we want to just match up what we have just to make sure it looks correct. So we're going to leave it at 0 and 0 on the X and Z. We're just going to increase the Y. Let's go ahead and go 25 studs above, and that should give us a nice result. So our curve is going to be based on a line from here to here and a line from here to here, and it should make a nice curve for us. And then we can move our control point when we need to. All right, so now back in our Bezier curve here, let's go ahead and make some variable references. So I'm going to go ahead and make a variable section here. And this is going to contain our 3 points to begin with. So we'll do local point A equals, and this is workspace dot point A. I'm going to go ahead and copy this, paste it twice, and then we'll just change this to B and this to C, this to C, and this to B. Now we have references to our 3 parts. Start, our end, and our control point. All right, now let's go ahead and make our next function. This is going to be a function called CreateCurve. And I should note, since we are actually just using these locally, we can just make these local functions. We'll do that real quick as well. Local function, and this is going to be CreateCurve. So this CreateCurve function is going to need the position of those 3 parts we just made. So we will use very similar parameters here, P0, P1, and P2. The first thing I'm going to do inside this function is set up a folder for our generated parts to be placed into. So every part along the curve, every point along the curve is going to spawn a part. And I want to just keep things organized in my workspace by putting those into a folder. This is specifically for debugging with the visual aids. So I'm going to have the function create the folder for me rather than making it in the workspace first. If you want, you can completely skip this part. It's just to keep things nice and tidy for me, and that's always good practice. So to do that, we need to instantiate a folder variable. We'll do local folder like so. We're not giving it any value. We're not turning it into anything as far as a table or a number or a string, just local folder. We do this since we're going to use this variable outside the scope of the following if statement I'm about to make, and then we go ahead and run that if statement. So let's say if, we'll go workspace dot, find first child, and we are going to look for a folder. Let's call this curve parts. So if our workspace find first child curve parts, if we get a nil value as a return of that check, in other words, if it doesn't find a folder or anything, an instance called curve parts, then we want to go ahead and create the folder. So this is quite simply going to be folder. We're going to assign a value now to our folder, which is going to be instance.new, because we're creating a new instance. This is going to be a folder. And then we can go ahead and assign some values to this, for example, folder.name. And this is, of course, going to be the same thing we just had up here, which is curve parts. And then we're going to go ahead and parent our folder, so folder.parent to the workspace, just like so. That handles if we don't find curve parts. What happens if we do actually have a folder or an instance of any sort called curve part? Well, in that case, we just want to assign our folder variable the value of basically referencing that curve parts folder. So we'll just do folder equals workspace dot curve parts. So this just kind of handles if there's an error of any sort, if the folder already exists. If the folder doesn't exist, we don't need to create another folder, and that's it for that if statement. So with that out of the way, we can begin the code to create our curve part. So we need one more variable here, and we'll call this part number. So local, correct. We'll say part number, and I'm going to set this to 0 by default. So this is going to keep track of which part we're making. This is really only valuable for us calling out which part we need our seagull to fly to later, but it's good to set this up. So we're going to loop through our t value that we mentioned earlier, which, if you recall, is a parameter that ranges from 0 to 1. So it's going to be a super simple for loop. So let's go ahead and do for I equals 0. Little spaces here. For I equals 0, that's where we're starting, and then we are, of course, ending at 1. We're also going to put in how much to move forward every single loop from 0 to 1. So in this case, I'm just going to do 0.1. So at 0.1, we're going to be making a point on our curve at every 10%. At 0.01, for example, we would be making a point every 1%. So while using the debug feature and making parts to visualize our curve, that also means we'd only be making 11 parts at 0.1, but 101 parts at 0.01. So if you're worried about performance during the test, just keep the number at the higher amount. Not to mention, since we're actually going to be using tween service for our Seagull's flight path, I find 10% to be pretty much plenty here, so we'll just do 0.1. So we'll do for I equals 0, 1, 0.1, do. So now the first thing to do in our for loop is to actually increment this part number value. So let's go ahead and go part number equals, and we could do part number plus 1, right, which would increment it, or, nice little shortcut here, is just do plus equal 1. Every time we loop through this, we're going to increase our part number count by 1. Now for our debug visualization part. So the parts that will show us what the curve actually looks like. So we want to go ahead and create a new part. So we're going to go local part, what we're going to call this, and this is going to be instance.new, and we are making a part. The first one I'm going to do is just give it a color. So I'm going to do part.color, and this is going to be a color 3. I want mine to be like a yellowish gold color that I kind of settled on. So we'll do color 3.new, and our 3 values, I'm just going to insert 1, 0.7, and 0. And you can see that makes this nice little gold color here. So all of our little curve parts are going to be that nice gold. We want to include a transparency line here for us, so we'll do part.transparency. So we'll make that 1, which would make it completely transparent, but I'm actually going to come to the beginning here and I'm just going to comment that out for now. While we are actually debugging, we want to see those parts. Alright, so I'll scroll down a little bit here. So a few more things we want to do. We want to go part.canCollide. This will turn off collisions when we have this to false. The reason we want that is we want our Seagull to actually fly through the center point of the part, as opposed to trying to avoid the part, which it would do if there's any sort of collision there. Let's go ahead and set the part size, so part.size, and this is going to be a vector3, spell that correctly, .new, and we're just going to set this to 0.5, 0.5, oops, and 0.5. So half the size of our starting control and end point. We need to make sure our parts are anchored because it's obviously going to be spawning them somewhere along here up in the air, and we don't want it to spawn them and them immediately fall down. That's not going to help our bird actually fly. So we'll go part.anchored, and we will make that true. Let's go ahead and give our parts a name. So each part is going to be named based on the part number that we're on. So quite simply, I'm just going to say part number. So every part that it goes through, part 1 is going to be named 1, part 2 is going to be named 2, and so forth and so on. And that just helps index those parts later on. So most importantly for these parts, we actually need to get their position and set them to where they're going to be on the curve. So let's do part.cframe, which is their coordinate frame. That's where they're located both positionally and with their orientation in the world. All right, so we need to create a new cframe value here. So we'll go cframe.new. And this is going to call our function here. So we're going to do our quadBezier function. If you recall, this takes 4 arguments. So t, 0.0, 0.1, and 0.2. We of course have our 0.0, 0.1, and 0.2 being passed in here. Our t is going to be our I value. So wherever I is on the for loop. So we'll just do I, and then we'll do 0.0, 0.1, and 0.2. And that will feed those numbers in, those positions in, and get us what we need there. However, this is just passing the part itself in, is what we're going to do. So we need to get the position from these. So we'll do dot position. You want to get some sort of autofill as far as when you're starting to type like that. You could actually go in here and say that each of these, put a colon here, is a base part, and then, well, and that just lets the function here know that whenever we're calling this, this is a base part. So we can now say dot position. You can see it autofills there for us. Not super necessary unless you're doing a lot of code that you're going to need to recall that with a lot. In this case, we really aren't, but it is what it is. All right, so finally, we now want to parent our parts, right? And our part.parent is going to be our folder that we created or referenced earlier. And that's it for the function for now, though there's one thing we'll need to add once we go into the Seagull part of this. We'll save that for when it's relevant. So let's go ahead and minimize that down as well. So let's call our function. Let's do CreateCurve. And now we're going to pass in our 0.0, 0.1, 0.2, which is going to be our point A, point B, and point C. And you can see when I run the simulation now, we have a Bezier curve, and it's working as intended. And this looks very similar to the curve that we have on the other one. And what I could do to make this actually a little more accurate to the image that we're using is set this to the same distance that our control point is, just like they have in the image. And if we run that, you see now we have proper curve there. So this is what we're going to have our Seagull actually say. I want to fly to this point, then to this point, this one, this one, this one, this one. And it moves through each point, moving itself that way. So if we move our control point, we want to move it over here, for example, and we run, you can see that the curve now switches to the other side. If we shorten it, we have a much shallower curve. And if we lengthen it, here somewhere. And then we have a much higher curve. We'll go ahead and move it back down a little bit and move over here. So to demonstrate it even better, let me go ahead and drop our iteration number down. We'll actually do the 0.01 to give us 101 points generated here. So when I run this now, you can see a much more significant line for our curve doing this. Now, of course, if I spread this out further, this would end up being spaced out a little bit more, but this is kind of a nice way to visualize what kind of curve you might want to go for. So that's a nice, smooth Bezier curve. While the game is running, I can't actually affect this. Like if I move my control point over, it doesn't do anything to the curve. So for that, we would need to do a while loop. So let's give that a try. So let's minimize this again real quick. So above our CreateCurve function call, we're going to go ahead and do while true do. This will be an infinite loop, of course. We're going to go ahead and place our CreateCurve function inside of this loop. Since we're making 100 parts each time we call this function, we definitely don't want to continuously add parts like that. So we need to make sure and destroy our previous parts on each iteration. The easiest way to do that is to delete the folder. So remember that our function starts by checking if the folder exists, and if it doesn't, it creates a new folder. So our function's actually already set up to always work whether there's a folder there or not, so we can safely delete that folder. So let's do workspace dot curve parts, and we're going to destroy. So we also need to be sure to add a wait in our for loop, or sorry, in our while loop, since it's an infinite loop and we'll actually break things if we don't. So we're going to go ahead and place it pass.wait right here between the CreateCurve function and us destroying our folder. We want to do that so that the points exist long enough during our loop before we destroy them. So now if I run the simulation, you can see that we've got our line still, our curve. But now I can also grab our control point and move this, and you can see in real time it is actually following along there, which is pretty nice. I can also, of course, move any of the other points. If I want to move this one further out, I can. Move this one up, I can. So at 0.01, that's a lot of parts to do this with, so let's go ahead and jump back down to just 11 parts with our 0.1, and then we can run this again, and now you can see that it's going to work nice and smooth for us. A little bit smoother even because it's not having to generate so many parts at once. So you can see that by playing around with this control point, you can get a good idea of what position you need to have the control point in order to achieve whatever type of curve you're after. And you're not limited to 2 dimensions like this either. So you can also move it from side to side, right, because you are in 3 dimensions. Or you can even have this completely along the ground. But if you're going for some sort of walking path using a curve or anything like that, you can use that there as well. So now that we have the curve, let me show you a simple practical use for it by having a seagull use the curve to fly from a landed position at our start point along our generated curve and land at the end point. So to do this, I'm going to go ahead and spread this out a little bit. Let's go ahead and put this back at the 40 is fine. And we'll leave this over here, I think sounds good. A little closer to the start point, we want to take off a higher angle and then kind of shallow out and glide down. So first thing, we need our seagull, which I've actually already copied in here. So I'm going to go ahead and move our seagull over here now. And you can see he's just this guy here. So the model and the animations I'm using for were paid for, but you could do this for any partner model. Just to show you what I have with this setup with the seagull, I have animations for a fly, a glide, and an idle. We're only going to be using the fly and the idle in this one. On the next video, we'll end up using the glide to make things just a little more advanced. But for now, we're just going to use these. The seagull isn't going to be player controlled, so I don't have a humanoid or an animator on there. We have the animation controller and an animator. And then of course we have the mesh, which is the model. So let's start by moving our Bezier curve into our seagull model. And we're going to go ahead and rename this to movement, since it's going to be handling the seagull's movement in game. So back in the script, we need some more variables. So I'm going to put these down here. We're going to say that we need to reference, of course, the model of the seagull, the mesh of the seagull, and the animations of the seagull. So let's go ahead and do local model equals script.parent. We'll do local, I'll call this gull as the actual mesh. And this is going to be model.seagull. And then let's go ahead and grab our animations and let's load them into the animation controller animator. To do that, we simply do local, and we'll start with a fly animation. Let's say call it fly anim, spell it correctly. We'll call it fly anim, and this will equal model dot animation controller dot animator, and now we're going to use the method load animation, and the animation we're going to get is going to be model dot animations. Access that animations folder, and this is going to be fly. So I'm going to go ahead and copy this line, paste that there, and instead of fly anim, we'll call this idle anim, and then everything else is going to be the same, except down here we just need to access the idle animation inside this folder. Alright, so that's all the variables we need to access for the seagull itself for now. But we are going to also do one more variable, again putting these above these. We're going to go ahead and create a table here. So this table, we're going to call curve points. And this is just going to be an empty table for now. This is where we're going to put each of our curve points positions into, and that's going to make it a little easier for our seagull to access those. So lastly, as far as references are concerned, we're going to go ahead and reference a service. So we'll go ahead and put our services section up here. And as I mentioned, we're going to be moving our seagull using the tween service. So we're going to go ahead and go local. Let's capitalize that. Tween service equals game service, and this is the tweens. And that allows it to move smoothly from one point along the curve to the next. Now let's come beneath our CreateCurve function, and let's make another function. We're going to do local function, and this is going to be called FlyPath. It's initially going to look pretty similar to our CreateCurve function, and like that function, we're going to pass in our 3 points. So we're going to grab our, I'll just grab them just like this. But because we're not going to always be using base parts for these, I'm going to go ahead and remove these type settings here. And just keep things simple like that first. So now we're initially going to have our seagull take flight when we hit run or play. So let's make sure the idle animation isn't playing and the fly animation is. To do that, we'll just call our idle anim and we'll tell it to stop. And then we'll call our fly anim and tell that to play. Next, we want to populate our curve points table that we made up here. We want to put the position of each of our curve parts. In order to do that, let's go ahead and open up our CreateCurve function again. And at the end of our for loop here, so right after we've parented the part to a folder, each time it creates a part, we can insert the part.position to our curve points table. And we do that by simply saying table.insert, and we need to reference the table we're doing, which is our curve points. And then what are we inserting in there? We're going to say part.position. So that is going to save every single part's position as a reference in our curve points table. And now we can have our CreateCurve function return a value. We're going to say return, and we're going to have it return that curve points table as it's populated that way. So we can go ahead and collapse this again. We don't need it. Back inside our FlyPath function, let's assign the curve points table the CreateCurve function and pass in our 3 points. So we're going to say curve points equals, and we're going to do CreateCurve, and we've already got references to our points here, so copy those into there. And that's going to, of course, return what we need. It returns the result of each of those generated parts positioned on the table for us. So now let's go ahead and set up our tween info. So we want to start with how long we want it to take to fly from point to point. So I'm going to do local tween time. And this, I'm going to start with 0.3. I just find this to be a good starting value. This is definitely something we can adjust later on. And then let's make our actual tween info. So we'll go local tween info equals tween info.new. And you can see this needs a few different things. We have time, easing style, easing direction. There's also a repeat count if it reverses, and if there's a delay time. We're going to use the default for a couple of those, but our time obviously is going to be our tween time that we just made. We are going to use enum.easingStyle.linear because we just want that to be a linear motion. And then our easing direction is going to be in, which is forward. So we're not going to have it repeat. We don't need any delay. We don't need anything else. We're going to just use the defaults for the rest of that. So we're good on our tween info. So now let's loop through each positional coordinate we have in our curve points table and tween the Seagull's C-frame to each one. Since we may want to change how many points there are on the curve at some point in the future, let's just use the number of values in the table as our stopping point. So we'll do for I, we're going to start at 1, and we're going to move through to the end of our table, which is going to be the number of values in curve points. So you can do that with a hashtag curve points there. And then we're going to do, so now we need to create the tween. So let's do local tween equals, call our tween service, and we're going to create. So we want to move the instance of the gull. So I'll do our gull variable, which for gull is just our mesh, our seagull mesh. Our tween info is already handled, so we'll just fill in tween info there as that variable. And now what we want to actually change has to be in a table. As you can see, it's a property table. So to make that, we just do our curly brackets. And what we're changing is the C-frame of our gull. So we're going to say C-frame equals, and we just need to set the target C-frame to be the coordinate point we're currently looped on. So in other words, C-frame.new, and then for our vector 3, we're simply just going to put in curve points index I. So whatever index we're on, if we're on index 1, it's going to be the first value in our curve points, which should be the first part that's generated on our curve. And it goes so forth and so on through that whole curve that way. Then, still in our for loop for now, we obviously need to actually play the tween. We'll go tween and play. We also want to make sure to wait for the same amount of time that we're tweening. In other words, if it takes us 1 second to move from one point to the next, we want to make sure that we're waiting 1 second before setting the next point in our curve as our destination. So that's simply going to be a task.wait, and we already have a value for this. It's our tween time. All right, and then once the seagull loops through and moves through each of our curve points, it should reach the endpoint, which is back on the ground in this case. So let's do the opposite of what we started with here. And let's do our fly anim stop and idle anim play. All right, let's shrink that down for now. So let's go ahead and replace our CreateCurve function with our FlyPath. And since it's actually passing in these same points, we don't really need to do much else there. So we'll just say FlyPath and then pass those points in. And I'm also going to go ahead and insert a couple of seconds into our wait here. That way it'll fly from one end to the other. It'll wait 2 seconds before it starts over again. So we can kind of see it looping through since we're in this while loop. So let's go ahead and run the simulation now. Pull back here so we can see. And if we run this, you can see that it's smoothly flying from one end to the other. Waits a couple seconds. It should zoom itself back over here to start the whole path over again. And there you have it, a simple bird movement script using Bezier curves. That's a lot to wrap into one video, given how much more we need to do to get the seagull to generate its own curve from wherever it lands. So in other words, once it lands here, it's going to basically remove all these points and generate its own curve to some location that it's decided it wants to fly to, and then it flies along that path that way. There's a bit to get into on that, especially when we also take into account that we want it to fly at a consistent speed no matter what distance its start point is from its end point. So I'm going to go ahead and call it here so we're not shoving too much into one video. Make sure to like the video if you found this useful, subscribe, hit the bell to be notified when my videos go up, including the more advanced bird flight video coming up after this one. And be sure to comment below if you're liking the content, what you think I could do to improve the content for you, and if you have anything you'd like me to cover, Roblox or otherwise. Until next time, thanks for watching.